Hey everybody, today we're working on something a little bit different. This is from my guys Diesel Central down under in Australia. We do some stuff for them. This is out of a Nissan Patrol. It's a JR711E 7AT RE7R05A. There's a lot of different things they're called. So I don't normally do stuff like this, but we don't sell rebuild kits for these units. He sent me these parts so I could do the machining, use our special components, and get all our extra clutches set up in it. And again, I don't normally do this. We do the builds in-house, but obviously for logistical reasons down in Australia, it's kind of very expensive to send transmissions back and forth, so we're going to try and do it this way. So this is what we have to start with. I'm going to try and go into a little more detail than I usually do. This is our input clutch drum. And we have 1, 2, 3, 4, 5, 6, 7 friction plates, 7 steel plates, and there's kind of a little cushion at the bottom. Some of them have that, some of them don't. Okay, so it's item number 1. The next is our high-low reverse clutch drum. And I'm guessing there's going to be 7 in here. Or there's going to be 5 in here. We're going to be able to get 7 or 8. So 1, 2, 3, 4, 5 frictions, 5 steels, and again, a little cushion at the bottom. This one's got an ID mark, and that was facing down, but I'm going to check that when we put it back together. The next is our direct. So these 2 snap rings are the same. But the one that retains the clutches is what needs to come out. See if this is going to give me a fight here. Let's just get a little buggered up. So again, we have a cushion at the bottom. We have 1, 2, 3, 4, 5, 6, 7 frictions and 7 steels. And we're probably going to be able to get, I don't know, 9 or 10 in there, depending. And lastly, in the pump, we have a 2, 3, 4, 6 clutch. This seems to have a lot of clearance, so I'm assuming they might have left the piston out. So I'm going to use a piston that we have here to straighten this out. So like in other words, what I'm doing is I'm sizing all these parts, getting the extra clutches in, clearancing them, and then we're going to send it back. But I'm going to have to use a piston that I have here to do this. So our 2, 4, 6, these are starting to burn. I see hot spots on here. We have 1, 2, 3, 4, 5 frictions and 5 steels. And we're probably going to get this up to, what, 6 or 7, Ken?
Definitely 6, hopefully 7, depending on the...
Yeah, this normally doesn't require machining. Fortunately, I have another one of these apart on the bench that I'm going to be able to use the piston from. Well, not on the bench, but over here, this mess on the cart is another unit, which is it's a 2016 Q50, I believe. But there's a lot of similarities. And also, I guess while we're on the subject, there's different gear ratios for these things. I don't know if you guys could see that. See the thickness of this ring gear? I don't know what the exact ratios are, but the Nissan Patrol stuff, it's tough to get information. It's not a US built vehicle. But at the end of the day, they're all kind of the same, but you have to, use the parts that match. Also, and lest I forget, we have a torque converter, which this is a diesel. So we're not going to raise the stall. We may even lower it, but we have some strengthening stuff that we do here. If you saw some of my other videos, there's a dampener assembly that comes apart in here. It's like riveted together at the factory, and it's garbage. So we TIG weld everything together so it doesn't have issues. And this valve body looks kind of brand new. I'm not sure. I'm going to have to contact Wayne down there and see, but this is going to get modified for performance use. So he's getting almost the whole IPT treatment, but he's doing a lot of the stuff himself down there. But as much as we can do, we're going to do for him. What's also nice is we got a bag of goodies. The people down under are so nice. Some Cadbury, I don't know what this is, but you can't get them here. Some kind of cookies. Afternoon tea. We tend to drink our tea in the morning here, but that's cool. Double coated Tim Tams and salted caramel brownie packs each. They know it's, I guess there's two of us here, one for me, one for Ken. And I was calling these cookies, Ken corrected me since he spent some time down under. They're biscuits. Anyway, thanks a lot, guys. All right, here's where we're going to start. On your input clutch drum, these are different frictions than the normal ones. These are a 40-tooth friction because they use a different planetary in this transmission. So everything's a little bit bigger. They had to make the clutches smaller. Sometimes we have to machine this piston down with our special parts, and sometimes we don't. We have eight frictions in here. So we're going from 7 to 8. I already checked this. I know it's going to stack up correctly. And I want you guys, you know, with any transmission, you want to soak your frictions in automatic transmission fluid for about a half hour before you put it together. But I'm sending this stuff to Australia, so I don't want all that getting shipped. So these guys are going to do that when they get it back. So again, we checked this already. And you know, with anything, you want about 5 or 10 thousandths per friction. I'm just checking for you guys to see, but you know, this stacked up correctly. There's some nice clearance. Okay, so next is the 2, 3, 4, 6 clutch. These guys didn't send us a piston, so we're using one of ours. And this is not really going to affect the clearance. This is going to be the same. So we have a return spring on the bottom. And we have 1, 2, 3, 4, 5, 6 frictions that we're putting in. So we have a little bit thicker of one on the bottom. And then the rest of them are specially made steels. So what the deal is here, we get the steels, they're made a little bit thinner. So we have more room to put an extra friction in. And then, you know, there's people out there and they say things like, well, if you have a thinner steel, it's more prone to warp and things like that. And yeah, maybe. But you got to remember, when they make factory steels, they stamp them out, okay? So when you stamp something, it's got a propensity to want to snap back. So the steels that we have made are laser cut, so that's not part of the equation. So between that and speeding up the shift time, it creates way less heat, and it's not an issue. We use thin steels in almost everything, and we just don't have the warping, and it's just kind of a myth. Where, you know, maybe people don't have the same parts as we have, so they want to, you know, knock us or knock anybody that's making thinner steels. But people have been doing this for decades to get more clutches and transmissions. So next we're working on the direct, and this is we are going to have to machine it. So I'm going to put it together and we're going to see what we have. Then I'm going to work backwards from there. And again, what do we have here? 1, 2, 3, 4, 5, 6, 7, 8. Would we go from 6 to 8? So we went from 6 to 8 on here, which makes a big difference. You know, these 4 clutch packs that we're working on are all responsible for making an upshift. And when they come in here, they kind of burn out. So having the extra frictions in there goes a long way to increase the durability and the power handling for these units. Okay, this is pretty much got no clearance, but the snap ring fits in. So what we're going to do is we're going to machine this piston to establish some clearance. All right, so I'm going to take this to the lathe and cut it down a bit. And I'm going to come back and put this back together. Remember, guys, safety glasses when you use a lathe. OSHA requirements. So we're going to take 50, 60 thousandths out of this, you know, keeping with our 5 to 10 thousandths per friction. And it's going to take several passes. I'm not going to, you know, bore you guys with all of that, but we're going to take it in. And we're usually able to take off about 10 thousandths per pass. And they do chatter a little bit sometimes, but it ends up being a nice cut. Okay, on the last pass, I only take a little bit off because it'll chatter less, it gives it a nicer finish. The finish isn't really relevant in a part like this, but you want it to look nice. And don't try this at home. Touch this with a little bit of sandpaper when we're done. You don't want any burns or anything like that on there. All right, so the piston's cut down. And just as a side note, if any of you guys are working on transmissions and these Nissans and Jacos, since the beginning of the time, these things like run a little bit more clearance than most manufacturers like. And the other issue is once these things are in the car, way more so than other transmissions, if you have to take one apart for whatever reason after it's in the car, these clutch clearances open up quite a lot. So we go a little bit tighter than normal on these, but it, you know, it works out well. So this, we have a little cushion spacer here. And again, these guys are going to have to soak the clutches when they get them back. Just about 60 thousandths. So that's good. So now we are down to our last component, the high-low reverse. And this is probably going to be the same thing. We're going to put it together and there's not going to be clearance. So all the machining I'm doing is to establish clearance. Now, if I'm working on the other units, like something that would be out of a 3.7 liter engine, they come through with less clutches to begin with. And then sometimes we're going to measure the thickness of a clutch in a steel and take that off in addition to what we're doing to establish clearance, right? So that's going to make room for an extra friction and steel, but you can't do these in these. Because what the problem is, your bottom friction could kind of get up under the splines of what's going in here, and it slides off it, and that's gonna blow your transmission up. So it's, you know, it depends on what you're working on is going to determine how much you could cut your clutch pistons and what you could do as far as the extra frictions. But again, I have a feeling we're gonna have about zero clearance here, just based on what usually happens. So I'm gonna do the same thing, 40 to 60 out of it. Well, this has a little bit. Not really enough. I'm just gonna have to nip it a little bit. I have about 30,000, so I'm gonna take, I don't know, 20 more or so. And let's do this and get back. Okay, so this is more of the same. We're just repeating the same thing we did before. And again, I take about 10 thousandths per pass. And you could, roll this by hand if you want, but I prefer the auto feed. It makes it a little bit nicer of a finish. But finish isn't really important on these. And this should get us pretty much to where we need to be. Another interesting to note, some of these parts are a little different between the, we'll call it the heavy duty and the non-heavy duty unit. The 3.0 units are a little bit stronger than 3.7s. Plus, this isn't a Titan, so that even has different parts than a passenger car would have sometimes. Sometimes they have steel planets and things like that, but you don't see planetary freight with these things. I mean, when these things fail from a higher power, pretty much clutch burnout, which we addressed, between the valve body work that we do and all the extra frictions. So we have what, 1, 2, 3, 4, 5, 6. So we're going from, no, I'm sorry, that's 7. We're going from 5 to 7 on here, which should make a big difference. So let's see if the clearance is where we want it. And if it is, we're kind of done for the most part. That's just about 55 thousandths, which makes me happy. You want, so we'll finish this up a little bit later, but I'm going to put the rubber seals in and we're going to assemble these drums. All right, but I like to get the clearance and everything correct to begin with. And this drum here is, he sent us a brand new drum and we didn't have to machine the piston, so that we're going to air check to make sure we have hydraulic integrity. Whoop, wrong hole. Okay, so as you see, that's like 100% solid of an air check, which is what you want. There's no leakage whatsoever. Very nice. All right, so I'm only going to have to work on these two drums. As we said, these two are going back the way they are. So the little bags are marked, in case you guys don't know. Hopefully we could figure this stuff out by now, but they mark the bags. And what I use here as assembly lube is ATF mixed with STP oil treatment. And you can use other stuff. It's just what I like. Kenny likes the regular trans gel, which is the same kind of package as this. I just reused the container. And this one you kind of can push into place. On the direct, it's a little bit tighter, so I'll show you guys how I did that. And if you guys notice, a lot of these videos seem similar, even though they're different transmissions. But these transmissions are made by the same manufacturer, which is Jatco, the Japanese automatic transmission company. And a lot of the parts interchange or are similar. And on this, we have a smaller seal on the top than we do on the bottom. So just be aware of that. But if you put it in, you know, it's not going to look right. Although some guys watching this don't know what looks right and what doesn't. But, you know, guys that are working on transmissions all the time would pick it out. So usually you could push stuff into place, but on these they're pretty tight. So I just use the spring compressor and I push them down like that. And some guys will, like, you know, tap on them with a hammer and a metal piece, but this I kind of like a little bit better. Went down nicely. So there's kind of two steps. We have these balance pistons. All right, that's a return spring. And we have these balance pistons that go in here. And they don't really seal anything. There's a rubber seal on the outside, but there's nothing on the inside. And what their purpose is to prevent centrifugal clutch apply. So in other words, residual fluid in the drum could try and put these clutches on. So there's a balance fluid that goes in the outer piston to counteract that. All right, so you don't want to seal that in because then your clutch won't be able to apply. But this is stuff that goes way back a long time. Back in the day, if you used to do turbo 400s, turbo 350s, you would have this problem with centrifugal clutch apply. So say you were in the water or going down the track, and you're in first gear, that drum is spinning at 2.5 times engine speed. So the oil, say you're at 7,000 RPMs, do the math, you're to 2,100 RPMs or whatever. It pushes to the outside and puts the clutches on when they're not supposed to be on, and it burns them out. So a lot of modern transmissions have gotten around that. And some of the reason is not because you're doing massive RPMs, but some of these things have like first gears that are like 4 and change to 1, and stuff gets turning pretty damn fast. So it's probably since what, maybe the 90s, you know, you start seeing that balance pistons in a lot of things. And people go crazy thinking like, oh, we got to change the balance piston because it's got a rubber seal on it. And again, it's not really designed to fully seal. That's not the point of it. It's just to, you know, balance, as the name would imply. So just much like everything else, you got to compress these down, open up your snap ring, and put it in here. If you guys aren't familiar with transmissions, there's little raised tabs here, okay? And that is to lock that snap ring in. I mean, not that it should really come out because you have spring force working up against it, but it's kind of like when you have what, suspenders and belt at the same time, where the expression goes. And this one you got to kind of balance because the bottom of it isn't that big. So now all that's left is I'm going to pre-assemble these things. And when they land down in Australia, these guys are going to soak the frictions, put them together, and they're rebuilding the whole thing. So there's a whole, you know, the rest of a rebuild kit that needs to go in. All I've really messed with here are, you know, our special stack-ups where we had to do machining and whatnot. I think this come in 4 boxes, Ken. Yeah, this is crazy. When you send boxes down to Australia via UPS or USPS or FedEx, there's sometimes $250, $300 a box for a 20-pound box. So what we're shipping back is all this stuff, and a torque converter, which is what, 42 pounds on these or so. A valve body, which is 20 pounds, and those are things you don't want to put in the same box. It's I tell people never to do that. Sometimes you receive stuff like that here, and the torque converter is like a landmine, and a valve body is like a, I don't know, crystal vase. It's beat the shit out of it on the way, and it's never a good mojo to send a valve body and torque converter together. But yeah, we're just gonna kind of stick this together a little to make it a little more compact, and get it shipped back. Please like, share, subscribe, and hit the notification bell.